we have one application problem involving a log. So our last example, example 8, says based on the data from 1920 and projected through 2050, the lifespan of people in the United States can be described by the function f of x, where x is the number of years from 1900. To use algebraic methods to find the birth year for which the expected lifespan reaches 78 years. So if we're wanting to know the birth year, we're wanting to know when, we're finding x, this tells me my f of x. Okay, so let's substitute 58 into our f of x. And we need to solve for this x here. So we are using our steps from the previous page to solve this. First, we need to isolate the log. So I need to subtract this 877 over. Oops. We get 69.23. Okay, now I need to divide by 14.9. And so I just subtracted, so all I need to do is just divide. It takes your last answer, divide by 14.9. Okay, now we get a decimal. Decimals aren't good. So I'm going to change this into a fraction, so you can either use this awful number or just leave it like this, which is this number. All they did was multiply by 100 to move that decimal over twice. So 69.23 divided by 14.9 equals my natural log of x. So I have isolated my exponential. I can't use this property since we don't have a log on both sides, so we're going to rewrite. Natural log is a log with a base of e. So base to the other side of the equals is e to the 69.23 divided by 14.9. And that's going to equal what's left over. So I'm going to just put this equal on the other side. And so when I put that in my calculator, what do we get? And we're rounding to the nearest whole number as needed. So since I already have that number in my calculator, all I'm going to do is do second E, and I'm going to go up here and highlight that number. And we get 104.2. Which rounding to the nearest whole number is 104. So if I'm wanting to know the birth year at which the expected lifespan reaches 78 years, and X represents the number of years after 1900, we need to add the 2. So what is 1900 plus 104? And we will get in 2004. Now I have a note in my notes that it could be an or 2005. So if that number doesn't work, try going to the next year. Now B wants us to use graphical methods to determine the birth year from which the expected lifespan reaches 78 years. Does this agree with your solution in part A? Okay, so we will put my y1. If this is my equation here, I'm going to put my y1 as my left side, and then my y2 will be my right side here. Okay, we need to adjust our window. So we need to figure out what is my X min and what is my X max going to be. Well, it says up here, based on the data from 1920 and projected through 2050. So I would probably use these years right here. If X is the number of years after 1900, we're 20 years past, and then this one here would be 150 years past this 1900. So I'm going to do X min of 20. That's representing 1920, and X max of 150, which is representing 2050. So let's change this. We'll do zoom 0. And then we need to find the intersection. Okay. So y equals, let's clear out all of that. My y1 is 78, and my y2 is my equation. Okay, then we'll go into window. I'm going to go 20 to 150, and then hit zoom 0. Okay, I can see that intersection. So second calc for number 5, enter, enter, enter. No, enter. And we get that 104.2. So the question is, does this agree with my solution? Yes, it does.